Hey, I told y'all I was going to get back with some complex number operations. So, right now, I don't have my camera, but I have my handy dandy tablet. So, I thought I'd work some stuff out for you real quick and then I can share that, right? So, let's start with adding and subtracting the complex numbers. And remember, when we talk about complex numbers, we're really just talking about I, right? The imaginary number I. All right, so let's just say you have something like 3 minus 4I or something, and then plus we're going to say negative 2 plus 6I. So when we're adding and subtracting, it's still the same. We're combining like terms. Okay? Combining like terms. So because we're adding and subtracting, remember I told you rules never change. So we're going to look for like terms. These are like terms because they have that imaginary component attached to it. And then these are constant values, right? So we're going to do just what it says. 3 plus a negative 2. My signs are different, so I subtract the values and keep the sign of the biggest number. That means, so again, we said 3, right? This 3, and then plus right here, and then this negative 2. That's going to give us 1, right? I told you don't add a equals, don't put an equals if it's not necessary. So we're going to say, oh, sorry about that. We know that that's 1. And then we have a negative 4I plus a 6I. And again, the signs are different, right? 4 and 6. So I'm going to subtract my values. 6 minus 4 is 2. They both have an I, so I know it's 2I. Oh, the 6 is positive, so it's positive 2. So your answer always goes in the format of real plus or minus imaginary. So our real number was 1, and then we had a positive 2I. So 1 plus 2I. All right. Same thing with subtraction. Let's say you have 12 minus 5I minus, open parentheses, 8 minus 3I. So on this one, rules never change, just like we know it, right? So let's go ahead and guess we're combining like terms. For me, I'm going to go 12 minus 5I, and I'm going to distribute this negative. Since it's outside the parentheses, I'm going to distribute it to everything inside so I know exactly what I'm working with. That becomes a negative 8, and a negative times a negative is a positive. So that's plus 3I. And now again, I can combine my like terms. 12, that's a positive 12, and negative 8. 12 minus 8 is 4, and minus 5I plus 3I is negative 2I. So I think you get it. I'm pretty sure you're good with the adding and subtracting of complex terms, right? And so I know last time we left, I was trying to tell you my favorite. Let me slide up here. My favorite way to remember. So I know it's a little different if you can't see my face, but still, hopefully you can hear my voice and you can remember, I won, right? So when it comes to that, we're going to do I won. And then we make our middle two values negative, right? And again, we know that we're doing the every fourth power of I repeats. So I is I to the first power, negative I is I squared, I to the third power, I to the fourth power, I to the fifth power, I to the sixth power, I to the seventh power, I to the eighth power, and so forth. And remember, I showed you if you had I to the, I think I did 1738 in the last video. So we'll do 1999. I don't know. But we'll take it and we'll do 1999. Divide that by 4. 4 goes into 19, what, 4 times? That's 16. 39. 8 times 4 is 32. Oh, wait, 9 times 4 is 36. Well, 36. I'm going to put my subtract in there so you remember. And then 39 again. 9 would be 36. So here we see our remainder is 3. So I to the 1990 to 1999th power is the same as I to the third, and we know I to the third power is negative I. Right? See how that works? Because our remainder was 3. We know that we took this number, we divided it by 4 because we know every fourth power of I repeats. So we divided it by 4 and we got our remainder. This is the even amount of 4 that goes in there, so we're not worried about that because it's the even amount. But our remainder, in this case it was 3, so we know that I to the 1999th is the same value as I to the third. And when we talk about I to the third, we know I to the third is negative I. Okay, hope that helped. Break that down a little bit more, let you see it with different numbers. And I had I wonder, did anybody tell you what to do with this? What if you had I to the negative third? What would you take that as? What would you do with that? I to the negative third. Now this means you have to have your rules for exponents down, right? Because we know there's no such thing as negative exponents, or we're not allowed to have them. It's not that there's no such thing, but we're not allowed to have them. So in this situation, typically we would flip it, right? I know you think, oh, I'm going to flip it, but we're trying to evaluate what I to the third is. So what if we didn't flip it first? What if we said, if we rewrote it, and you always want to think about this, can you rewrite? What if we rewrite it as I to the negative fourth, hear me out, times I, right? Because the rule for multiplying exponents says that we add them, and negative 4 plus 1 makes negative 3. So if that's true, then what if we rewrite this as I to the fourth, and we do that times negative 1, right? Because we're still incorporating our rules of exponents, times that I, right? And so now that means I to the fourth, what did we say it was? What's I to the fourth? 1, right? So that means we have 1. Oops. That means we have 1 to the negative 1 power times I. Can you see that negative? Let me rewrite that. To the negative 1 power to the I. And now this, if we flip it, it doesn't matter, right? Because 1 over 1 is still going to be 1. So now if we flip it, we do that 1 over 1 to make this negative go away, because that's the rule to get rid of negative exponents. That's still times I. So our final answer is just I. Interesting, right? Play around with your math like that. Rules, that's how they work. That's how it works. Okay, so now let's get to what you want to see, right? Let's break it down, break it down. So, let's say that you have an equation. How much time has it been? 10 minutes? Okay, we're good. All right. Let's say you're given, what do I want to show you first? Okay. I'm presuming, have you guys done conjugates? I'm going to say that you have done conjugates. Okay. So say you have 7 plus I over 3 minus I. Right, so how do you solve for this? How do you simplify this? How do you reduce this? How do you write this properly? So, or because you're like, wait, what am I even solving? Well, let's hear some stuff out first, okay? Let me first remind you. Let me see if I can change my color up here to point out some stuff for you. Let me first remind you that this is a fraction. Okay? Fractions represent division. Okay? So you can't change that. This does say 7 plus I divided by 3 minus I. Okay, so there's one thing we have to look at. We're dealing with fractions. Okay, another thing is just like with radicals, we can't have imaginary numbers in our denominators. So if you remember, and if not, we'll go back and we'll talk about this. Let me see if I can write this down. We're going to use a a conjugate. Conjugate means opposite. Basically, that's what it means. So if we have 4 plus 7, the conjugate would be 4 minus 7. Okay? If you have 3x plus 8, the conjugate would be 3x minus 8. Okay, so we're going to use conjugates. Anytime you have a radical or a imaginary number, in the denominator, you're most likely going to use the conjugate. I don't know why I do that. And you know what? I think when you have binomials sometimes, like these are binomials. So radicals, imaginary numbers, what I just say, binomials sometimes. And this again is how you're going to go about solving them. And definitely when you have rational functions. Okay, but anyway, so we're going to evaluate this. We have to divide 7 plus I divided by 3 minus I. So we look, the first thing we recognize, okay, we have a rational expression, right? Fractions is rational, right? So it's like a rational expression. And it's something else we know, we can't have 0, right? Can't have 0 in the denominator, right? We can't have 0 in the denominator because it's a fraction, and anything divided by 0 means that it's going to be 0. So therefore we can't have a 0 in our rational functions in our denominator. So when we look to solve this, we're like, okay, we have to divide. It's an imaginary or a complex number, so I'm going to have to use a conjugate. All right, so here we go. Here we go with the conjugate. We had 7 plus I over 3 minus I. And you know I hate equals, right? Don't throw out equals. Equals means is. So to solve this, we said we have to use the conjugate. So we'll do 7 plus I over, this is our original, 3 minus I, and we're going to multiply by the conjugate, 3 plus, oops, I do that a lot. It's not my eraser yet. Just erase. 3 plus I. And as long as it's the same, then we know that that's 1. Okay, so here's our conjugate. That means now we're going to have to, you guessed it, what do we do when we have two binomials next to each other? Now we have to FOIL, right? So our next step, so our first step, step 1, multiply by conjugate. Right? So we're going to multiply by the conjugate. We're going to FOIL our numerator and denominator. So 7 times 3. And if you can't remember, I'll do it over here. Alright, and so we'll do 7 times 3 and 7 times I, and those are both positive, and then positive I times 3, and then I times I squared. And what's I squared? Do we remember? Ooh, I squared is -1. Correct. Very good. So when we simplify here, our new numerator, we have two like terms we can combine here. We have 21 plus 10I, and then minus 1, right? Because it's plus a -1, and you know you don't have to write plus -1. So 21 minus 1 makes 20 plus 10I. That's our numerator. Now let's do our denominator, right? We have 3 minus I times 3 minus I. 3 times 3. 3 times 3 first is 9. 3 times -I, -3I, -I times 3, -3I, and negative times negative is positive I squared. Again, rules never change, right? Combine our like terms. We know I squared is -1. We have 9 minus 6I minus 1. 9 minus 1 is 8 minus 6I. Okay. So far, oh wait, I'm sorry. I was sitting up here staring at it. I was like, hold on, I messed up something. Where did I make my mistake? Did y'all see it? I see it. I was like, something's not right. Okay, I chose the color. Right here. Mistake. Boom. Why? Because it's supposed to be plus. I was looking, I was like, I'm not supposed to have a denominator. Right? So, and this is what I always say, do with your mistakes. Remind yourself what it was. This is where my mistake was. It should have been positive. So we should have had 3 minus I times 3 plus I. Okay. I was wondering, I was like, you're not supposed to have much, you'll see, you're not supposed to have much of a denominator. So we're still going to FOIL. 3 times 3 is 9. And then 3 times that, the I is positive 3I. And then negative makes it a negative 3I. See? And negative times positive is negative I squared. So this one changes because it's supposed to be negative I squared. These will reduce out, right? Negative I squared is negative, and what's I squared? Negative 1. So we bring down our 9. Exactly, 9 minus negative 1 makes it 10. Yes, so our denominator is 10. So our numerator, that's so much better. 20 plus 10i, and our denominator is over 10. And so I don't know if you remember me telling you, but there's a rule way back in the math days that says if you have a plus b over c, that means you knew that you had a over c plus b over c, because fractions that share the same denominator can be put together with one, as one fraction. If they share the same denominator, like these have the same denominator, we can put it together as one fraction. So that means when it's given to us as one fraction, if we need to break it apart, then we can do that. And in this case, we probably will need to break it apart because they are all multiples of 10 and can reduce, right? So you would have 20 over 10 plus 10i over 10. And of course, these reduce to 2 plus just I. Now, had we not made that mistake, it probably would have gone a little bit quicker, a little bit faster. But here we go, working with the conjugate, right? Hopefully you got to see all this. We didn't have to erase anything. We just slide our little board up here, right? And I'll check this out. Hopefully everything recorded well for you. And if you like it, then you'll probably get more videos even sooner if you like this and everything looks good for you. All right, let me know if it helps you out. See you soon.